So, write year 11, you should have a booklet in front of you. If you don't, you can follow this lesson without a booklet, okay? So, date, you need to fill in whatever the date is for you. The title is Calculating Bond Energy. Keywords then, remember we need to be using these correctly throughout the lesson. Exothermic, endothermic, reactant, product and energy. And your starter activity is describe what's going on in the comic strip of collision theory next to these images. So what I want you to do is pause the screen wherever you may be and start thinking about what's happening with these images. So thinking back to the rates topic last year, the first thing that's happened is these are your reactants. So the things that you want to react together. So these are your reactants. And then reactants are colliding. Okay, remember particles are constantly colliding. It's only when they collide with enough energy, the energy known as activation energy, will they react. So collide with enough energy and then they react. When they react, as you can see here, bonds break. There as well, bonds break, and then in your products then you've got new bonds. So products form and they've got new bonds. Nothing has been made or destroyed. Okay, so you've still got, if we're just going to consider 2 orange ones, 2 blue ones, but they've rearranged themselves with new bonds, but you haven't made anything extra. Okay, so that's just going back and thinking about collision theory. Today we're going to calculate bond energies. That hasn't printed very well in your booklets either, I don't think. Okay, so as I go through, I'll be telling you the values. Some people can read it, but if you can't, don't worry. So calculating bond energies, you've got your Mendy-Proud at the top, your success criteria. So the first thing you need to do, so this one, just follow me through. Hopefully you'll be able to kind of get the gist of what's going on. So first thing you need to do, looking at the success criteria, is to label your reactants. Your reactants are anything that is this side of the arrow. Okay, so anything this side of the arrow. You could have 10 things lined up here, anything that is this side of the arrow. Okay, and then your products are anything the other side of the arrow. So you need to make sure that you're really confident in labeling your products and your reactants. So reactants, products. Okay, the arrow is the distinction as to where they are. Okay, so give that a tick because we've done that. Then it says add the bond energies for the reactant. So what bonds do I have in my reactant? So I've got this bond here, H to an O, and I've got this bond here, an O to a H. They are exactly the same bond. So whether I write the bond like that or write the bond like that, they are exactly the same. Okay, so put that in your reactant bond. So you've got HO, and I've got 1, 2, 3, 4. I'm just crossing them out so you can see and make sure that you've included them. So you've got 4 of them. Okay, that's all I've kind of got going on in my reactants. So what I would do then is I'd go back to that previous page with all the energies listed and I'd find the energy for the OH bond. And the energy for the OH bond is 464. So to break one of these bonds by here, it requires 464 joules of energy. So all I do, you can do it in your head or input into calculator maybe just to check. That is the answer, 1856. Okay, so that's all the energy required to break all of these bonds, these 4 bonds in your reactants. Then you've got to, so you can tick it off, you've done it. Then you've got to do exactly the same thing then for your products. Okay, so a little bit different here with my products. I've got this bond here, so I've got HH bond, and if you look at it, I've got 2 of it. I've got 1, 2, so I've got 2 of them. So put that by there. Okay, then I've also got this bond here. Okay, even though there's 2 lines, it doesn't mean you count it twice. It's just 1 bond. It's a double bond. It's still just a bond between 2 elements. So we've got O double bond. Okay, but I've only got 1 of them. Okay, it doesn't matter whether you've got 4 lines. Okay, it's still just 1 bond if it's 2 elements connected to each other. It doesn't matter how many lines, it's still just 1 bond. Okay, exactly the same thing then. We need to go to that previous page and check what the bond energies would be. So the bond energies 436 and 498. Like I said, in the exam they'll give them to you, and I appreciate that hasn't maybe photocopied very well on your one. Okay, so times them together, I get 872, and that's obviously 498. Okay, so you need to work out the total energy taken or required, sorry, to form these new bonds. Okay, so these are bonds breaking. Might want to write that there. Bonds breaking. and then these are bonds forming. So I've got to add these two over here up. So add these up to work out the total energy. Again, you can do it in your head, that's perfect, but maybe just check calculator to make sure you're correct, okay? So then it says, what is the energy required to break the bonds in the reactants? That's 1856. What is the energy required to make all the new bonds in the products? 1370, okay? And then you have to work out whether it's exothermic or endothermic, okay? And to work out whether it's exothermic or endothermic, you do reactants minus products, okay? So reactants minus products. So the answer we got, so we R minus P. The answer we got was 1856, take away 1370. Okay, so that's my total reactants, take away my total products. Again, if you feel confident doing it in your head, do it in your head. If not, check it on a calculator, and that gives me 486, okay? And it's either measuring kJ, or so kilojoules, or kilojoules per mole, depending what they give you. Check on your table, okay? This is a positive value, okay? This is a positive value, so positive values are endothermic. Okay, so if it's positive, it's endothermic. If it's negative, it's exothermic. Okay? So we'll have a go at one more, and then there's a load for you to kind of have a go at in your book, and then we'll check them. So exactly the same thing now with your reactants and your products. So you want to label where your reactants and your products are. So there's my reactants, there's my products, okay? A little bit more going on here. So looking at my reactants then, I've got CH, and I've got 1, 2, 3, 4 of them. So I've got 4 of them, okay? Now, what you might find easy by here is to cross out that 2 and then put, okay, because it's essentially telling us you've got 2 of them. So put O there, and it's times by 2 because you've got 2 of them. 1, 2, 3, 4, so just crossing them out, okay? I'll do exactly the same thing now on the product side. So I've got the CO bond there and a CO bond there. So I put CO times by 1, 2, okay? Same thing here, it'd be easier just to write it out. So we've got 1, 2, 3, 4 of them. So we've got HO, and we've got 1, 2, 3, 4 of them. Okay, exactly the same thing as before, check on your table. So once you've then collected the values from the table, times it by 4. So I've got 1652, again, times it by 2. So these values are coming from the table at the front. And then I've got them all together. The next thing I now need to do is add them up. So I've got actual values for all of my reactants and all of my products. 2642 and 155. Okay. Okay, so in the reactants then, 2642, in the products, 3414. Remember the equation is reactants, take away products, so we're going to do 2642, take away 3414. Again, input that into your equation, into your calculator, and that should give you minus 772. Again, check your units, it'll help you in the table. Moles minus 1, and then it's a negative value, so it's exothermic. Okay, so in your booklet now, there's quite a lot to go, okay? So this one's from a past paper, and you can kind of see how they laid it out in terms of them actually giving you the values for the bonds, and you can see that it's just in kilojoules, this one, okay? Next one then, same kind of thing. You can see here it's in kJ moles. That there is a triple bond, okay? That there is a triple bond, and it relates to that one there, okay? Whereas these are double bonds, and they relate to them ones there. Okay, so that should help you. And then with this one, it might help you to draw it out beforehand. Well, in the exam, you will get it drawn out. So it would look like that. So that's your reactants there, and then that's your products there. Okay, so I've just drawn them out. Again, KJ this time again, the same kind of thing with this one. You haven't got the table, so you kind of need to use how you want to do. If you want to draw out the table every time in the exam, you won't get the table in the exam, or you can just kind of do like how I've done, reactants and products. Okay, does carry on. I think that's the same one again. And then there's quite a nice hard one at the end. Okay, it's a little bit different. Again, I'm just going to put a couple of things in for you. Okay, so instead of 3 of them, we've drawn them out. CO. Okay, again. And there's 2 of them. And there's 3 of them. Okay, so that's just helping you out because I've drawn them out. With this one, it gives you all about information about ethanol. But then it says the overall energy change is this. So the final answer you get is minus 134. And you need to work out, you need to show how you would make sure that it's exothermic. So they give you the answer. So the problem is if you don't end up with the right answer. Be really careful with this, okay, because there's loads of bonds. That's a bond, that's a bond, that's a bond, okay? Be really careful. And then you will know if you're right because you should get to that answer. Okay, so have a go at them and then bring them back to me when you've done.